Global energy consumption is predicted to double by the year 2050. Meeting this demand using clean energy sources will require a bold leap. Fortunately, there is a technology that offers the potential for limitless energy with no carbon emissions. More than 99% of the visible universe is an energetic state of matter called plasma. Through the process of fusion, charged particles in plasma collide and release energy. Fusion is the fundamental source of energy in the universe and fuels stars like the sun. Harnessing fusion on Earth has been a goal of scientists and nations for decades. In the United States, the Department of Energy has led a long history of fusion research, beginning in the mid-20th century, when our predecessor, the Atomic Energy Commission, founded laboratories and programs to pursue fusion energy. A new scientific field was born, one requiring physicists, engineers, and mathematicians. The commitment to fusion energy in the United States and abroad has charted a course that envisions fusion power on the grid in the 21st century. To produce energy on the scale of a typical power plant, scientists today aim to build a fusion device that generates a self-heating plasma using a tiny amount of fuel. This journey began in the 1950s and 60s as scientists tested fundamental fusion concepts. Since then, they have developed a range of fusion devices and discovered other applications. To produce the energy gains needed for a power plant, a fusion device must meet some extraordinary conditions. The plasma in a device must reach extreme temperatures, up to 10 times the temperature at the center of the sun. So scientists demonstrated these enormous temperatures in laboratory experiments. The plasma must also be concentrated enough for many particles to collide at the same time. So scientists devised ways to stabilize and confine higher concentrations of plasma. The device itself must confine the hot, concentrated plasma long enough to produce useful energy. So scientists developed stronger magnets to confine and control the plasma for longer times at larger facilities. Today, government labs, universities, and companies are advancing many different concepts for a fusion power plant based on decades of DOE research. One concept, called magnetic confinement, has been the focus of major international efforts. Another concept is inertial confinement, which uses lasers or other methods to compress and ignite a small target of fuel in billionths of a second. Through the space age into the information age, fusion research became a driving force for developing new technologies with applications in manufacturing, medicine, and more. For example, scientists used plasma to develop smaller, more powerful computer chips. Meanwhile, fundamental research provided new insight into planets, stars, and the universe. Technology development also advanced the goal of practical fusion energy, resulting in new superconducting magnets and tools for understanding plasma and device performance. In the 1990s, 2 experiments, one in the United States and one in Europe, broke a string of fusion performance records. These experiments tested an abundant fuel known as deuterium-tritium, which are 2 forms of hydrogen. Deuterium is derived from seawater, and tritium can be made in a fusion plant from lithium. The end of the 20th century saw the initiation of the world's largest fusion collaboration, which includes the United States. The ITER device, now under construction in France, is expected to make its first plasma later this decade. Today, as part of DOE, U.S. fusion researchers have access to some of the world's top facilities in materials science and high-performance computing, which are key to fusion development. DOE manages 2 modern magnetic confinement facilities where scientists conduct experiments and share data. The department also leads an inertial confinement fusion program that uses high-powered lasers and pulsed power. And U.S. researchers collaborate abroad, connecting them to fusion innovations around the globe. There are more than 130 experimental fusion devices worldwide and counting. With surging private sector investment in the United States and emerging breakthroughs in science and technology, Fusion experts agree now is the time for a bold, decadal mission to bring fusion to the grid. Now is the time to bring a future of clean, lasting energy to the nation and the world.